Hello, math analysis. We are starting chapter 3. You must be psyched. Chapter 3 is awesome. We're going to solve linear equations and quadratic equations and inequalities. And yeah, baby, fun times. We got this. So, lots of solving equations in this chapter, as we can see, lots of solving inequalities in this chapter, as you can see. Just real quick, there are two quizzes in this chapter. The first quiz is after solving equations, solving inequalities, solving absolute value equations, solving absolute value inequalities, and solving rational equations, which is equations that have fractions in them. So that'll be like LCD, clear the denominator out stuff. Okay, we noticed there's 2 days of that. So 2 days of practice, and I'll do videos for both of the days. Okay, so we'll have all those, then a review, and then a quiz. Okay, so that first quiz is on those like their linear and absolute value types equations and inequalities. Then we're going to take a break from solving anything to review factoring. And I'm going to go over GCF and regular binomial factoring. I'm going to do binomial factoring when your A value, so your value in front of the x squared, is greater than 1. And I'm going to do factor by grouping. And then we're going to do a factoring only review. And the quiz, the second quiz, is only on factoring. So this stuff is factoring only. Okay. So this piece is factoring only. And I know I've done a little bit of factoring stuff throughout so far. I've done a little bit of completing the square, and so shown you some factors of your perfect square trinomials, that type of thing. But this will be a full on review. Okay. Cool. A little scary. I'll try to cut that out. So this will be a full on factoring review mid chapter. And there's a reason for that, of course, because then here we're going to solve quadratic equations and inequalities, and we will need to use factoring to do this. So this is going to be very basic solving quadratics. Okay, so we're not going to get into, in this chapter, we're not going to get into the major depth of completing the square and quadratic formula. It's going to be just solving by factoring for both equations and inequalities. Then we'll have an exam on the whole spiel. Okay, so all the solving will be on the exam. So the exam, when you have your chapter 3 exam, will be solving linear equations. Linear inequalities. How about I put a 2 there since I had started it? Finish it. Absolute value equations. That's new. That's algebra 2. Absolute value inequalities. That's new. That's algebra 2. Rational equations. That's not new, but we will just go a little more in depth than we did your freshman year. But we're sticking to just equations for these guys, not inequalities. And quadratic equations and quadratic inequalities. Okay? So when you go to take your test, it will be these 7 things that are on it. So out of all 10 lessons in this entire chapter, only 7 have to do with the actual solving stuff that will be on the test. The reason we have this factoring review is because you need to factor to do the last 2. So we're going to take the aside to do all the factoring stuff and be ready to go when it comes to that. having some power issues here. Now some lights are going off over there. Yikes. Well then, look. Chapter 3, Lesson 1 notes. Okay, that's what this video really is all about. Chapter 3, Lesson 1 notes. I went majorly in depth in solving equations here, but you should be able to do this by now. So this is not going to be a struggle. Okay, first things first. An equation is like a sentence where there is a noun and a verb. When you don't have the equal sign, that's just an expression. That's like only having the noun. Okay, there's not a full statement made there. Here, there's the full statement made, and that's the equal sign. So we can simplify expressions, but we solve equations. So way back when, on this old Regents exam, this question appeared with good old Chad here. Chad has his homework, and he complained to a friend that he had to solve 5 equations on his homework. Chad, come on. There are not 5 equations on this homework. In fact, there are only 2 equations on this homework because equations require equal sign. So get it together, Chad, right? The other 2 are just simplifying stuff because they're expressions. So this is an expression. Oh, just distribute, Chad. Come on. And an expression. Okay? So only 2 equations are actually on his homework. That's the first thing we want to really make sure we know. Okay, what's the difference between an expression and an equation? Now, when I'm giving you equational properties, we all know about the properties of real numbers, those 10 properties like the distributive property and the associative property of addition and multiplication, and the commutative property of addition and multiplication, the zero property, the inverses, the identities. We know about those. We also know about the properties of equality, which are like whatever you do to one side of the equal sign, you have to do to the other. You've heard about these properties too in geometry, but you might have that mental geometry block here. There are a couple other properties that we kind of don't talk about a ton when we're talking about equation solving, but they're important. For example, the reflexive property, any variable is equal to itself. Okay, so x equals x. So if you've got multiple x's in your equation, they are all representing the same number. The symmetric property is like when you have an equal sign, the 2 things on each side are the same. So it's the same to say that A equals B as it is to say that B equals A. It's the same to say x equals 3 and 3 equals x. I think that both of these are just knowledge. Like we just know that. We innately know those things, right? Now then you have this transitive property, which is pretty cool. Okay, it's just saying it's a drop the middleman property. If you know that A equals B and B equals C, then you know that A is equal to C already. Okay, so it's just like it's just saying, hey, if I know these 2 things are already the same, I can say that the last 2 are the same. All right, so if you know that these 3 things are actually the same, you can say those first 2 things are just equal to each other. You can drop that middleman out. Now, these are what you always use to add and subtract to both sides, or multiply and divide to both sides. It's just whatever you do to one side, you have to do to the other. And the addition property of equality deals with adding and subtracting to both sides. The multiplication property of equality deals with multiplying and dividing to both sides. What I did for you in here was I treated you like you were in 7th grade and solving equations for the first time in these notes. This is not something you have to go through. But if you haven't seen this in a really long time and you're genuinely curious about how I did this, please feel free and look. The goal for solving equations is always to get your variable alone. And we do opposite operations in order to do that. Okay, and so we use the properties of real numbers in conjunction with the properties of equality. All right, meaning if I know based on the commutative property that A times B is the same as B times A, I can manipulate things that are being multiplied together. If I know that if I do something to one side of the equal sign, I have to do it to the other, I can manipulate my equation to move things away from my x, and that's what I'm doing. Okay, and so here, that's what you're doing, is you're manipulating to move things from one side of the equal sign to the other. Okay, you are making the choices of what to add and subtract to both sides using an inverse, right? The opposite of 2 is -2. And if you subtract 2 to both sides, you have now canceled this 2 out because now you've got 0 over here. But this now has to do the same thing. Whatever you've chosen to do here, you have to do here. And that's what we do. Okay. So you're choosing I could choose any number to add to both sides, but it might not get me to my goal of getting my variable alone. That's what I'm showing you throughout here. Okay. And that's why I'm saying it right here. We chose to do -2 because it's the opposite of +2. Okay. That's us getting our variable alone. All right. Well, let's go. Equation or expression, right? So here's what the stuff getting ready for your homework is. How about I meant to zoom in a little further? Here's the stuff getting ready for your homework right here. Equation or expression. No equal sign, expression. Equation or expression, equal sign, equation. Okay. Now, if we have an expression we simplify, well, we know from earlier this is an expression. Simplifying would mean like distributing and or combining like terms. So here I'm just going to distribute that 3x. So 3x times x squared is 3x cubed. 3x times -5x is -15x squared. 3x times 10 is plus 30x. Are there any like terms here that can combine further? No, you're done. That's what we do with an expression. We simplify it. With an equation, however, you can simplify any expressions on one side. So for example, -5 times x is -5x, and -5 times +20 is -100. But now, because I've got an equal sign, let me move my cursor here. There you go. But now, because I've got an equal sign present, I use those opposite operations in conjunction with the addition property of equality, right? What's the opposite of a -10? -10? How about -100? Oh, +100. And because I'm choosing to add 100 to -100 so that I get 0 numbers there, I now have to do it over here on the other side of the equal sign. So that's where I get this 175 on this side from. Now, did I do anything with this -5x? No, I didn't. So I bring it down to the next line. Now, what's the opposite of multiplying by -5? It's dividing by -5. So now I divide both sides by -5. Those -5 divided by itself cancels out to a 1x, which is what I want. I want my variable alone on one side of the equal sign. Now over here, I've got 175 divided by -5, and I get -35. So 1x is worth -35. So anywhere I see an x up here, that's what I plug in for it, is -35. That is the real number that makes this initial sentence true. Okay, that's what we're doing when we're solving equations. More. Here's one I did for you. See, So I showed you using opposite operations to solve this, just in case you don't remember how to solve when you've got one fraction involved in your equation. But you're always dealing with whatever is being added or subtracted, the regular number. Move that first. So here, the opposite of a positive 15 is a negative 15, and you do it to both sides of the equal sign. So you get this 2/5 h hasn't been used yet. Bring down your equal sign because positive 15 minus 15 cancels to 0. And now here, 7 minus 15 is negative 8. Remember, fractions are just division problems. So right now I'm dividing by 5. And what is the opposite of dividing by 5? Yep, multiplying by 5. Okay, so now this 2h is left, and I bring that down to the next line. Negative 8 times 5 is negative 40. Okay, now you've got 2 times h. So the opposite of multiplying by 2, it's dividing by 2. And whatever I do to one side of the equal sign, I do to the other. So 2 over 2 cancels to a 1h, which is my goal to get your variable alone, get my variable alone, I should say. And now you've got negative 40 divided by 2, which is negative 20. Bell's about to ring, just so you know. Guys, that's it. That's what's on your homework, is this stuff. Solving linear equations. I know I explain in depth in the notes how to do that, but it's because these notes are your textbook to take on to the next level when you're ready. I know that's an Algebra 1 concept. In fact, I know it's a pre-Algebra 1 concept. Look at that. I can predict things. I'm like, oh, I'm awesome. Or it's the timestamp is at the bottom and you can see it too. Anyway, that's all you're doing for your homework right now. Nice and easy. Okay? Just review. But if you want any help with it, please let me know. I'm happy to help you. Okay? Okay. Well, I'm going to go back to sipping my tea. Apparently sitting by myself since none of you all wore pink today.
Andy Izzo, please come to the counseling. Please come to the counseling office. Andy Izzo, please come to the counseling office.
Well, that's a nice addition to our little video, isn't it? Gotta love it. All right, guys. I shall be seeing ya. Good luck. Let me know if you need me. Bye.